One-step equations, and now it's time for multi-step equations. So in general, you want to move things that are numbers away from the variable side. So whichever side has the variable, your goal is to move all the numbers on that side over to the other side. And this may sound crazy, but we talked about it in one step a little. No, we didn't. This may sound crazy, but in general, to solve for a variable, you will need to follow the order of operations backwards. For real. I know that seems totally wrong. How could this be? Order of operations is essential. When you're computing or evaluating, it is. But when you're trying to solve for a variable, you're basically having to work backwards to figure out what happened or what it was originally. So let's talk about that in number one. In number one, and I won't write this out this fully in all of them, but I want you in this one. In number one, they did two things. Whatever x was, they first multiplied it by 11. That was their first step. Then after that, they subtracted 4. But they did it in that order, and that's meant to be multiplication, not just an x. So they multiplied that number by 11, and then they subtracted 4, and the result was 29. So if we want to figure out what they got when they started, instead of moving forward, we need to move backward. So instead of subtracting 4, we will add 4 first, and then we will divide by 11 second. So we're going to do the opposite operations and do it in the opposite order. So 11x minus 4, I'm going to add 4 first. Then I'll divide both sides by 11, and I get x equals 3. Again, the idea is we're working backwards, because what they did is they multiplied 3 by 11. They got 33. Then they subtracted 4, and they got 29. So when we didn't know what they started with, we had to start with their ending, 29, and work backwards. Okay, so I'm going to use that same idea here. The first thing they did was multiplied by 7. Then they added 3. So if we're going to go backwards from that, we're going to have to subtract 3 and then divide by 7. So we subtract 3 from both sides. We get 7x equals 49. We divide both sides by 7. And we get x equals 7. Another way you can think about this is we're moving the number that's farthest away from the variable first. So like in this one, obviously 7 is the number physically closest to the x. 3 is farther away from it. So since 3 was the one that's farther away, we moved it first. Then all we had to the left to move was the 7, so we got rid of it. Okay, so we use that line of thinking in number 3. Take what's farthest away from the variable and move that first. Well, the 7 is up top in the same part of the fraction as the a. So it's closer to the a because they're both in the numerator. 8's farther away because we've got this huge line separating the two of them, and 8's in the denominator. So we're dividing by 8. We want to do the opposite. We'll multiply both sides by 8. So these cancel out, leaving just 8 plus 7. 5 times 8 is 40. So now all that's left is to get rid of the 7. So we subtract 7 from both sides and get a equals 33. And we were still following the rule I talked about up here with doing things backwards because they took this number a, and the first thing they did was added 7. Then they divided by 8. So to go in reverse, we would want to multiply by 8, which we did right here, and then subtract 7, which is what we did right here. Okay, so 4 is very similar. Zoom in a little, make it a little easier to see. The negative 2 is farthest away, so we'll want to multiply both sides by negative 2. The negative 2's cancel over here, leaving in plus 1. 15 times negative 2 is negative 30. Now all that's left to move is the 1, so we subtract 1 from both sides. We get n equals negative 31. Sorry about that. Number 5. So on this one, if I were to plug a number into 5, the first thing I would do is divide by 5. The second thing I would do is subtract 6. So to go backwards, I'll add 6 first, then I'll multiply by 5. The 6 is farther away. The x and the 5 are grouped out together. The 6 is farther away, so I'm going to move it first by adding 6 to both sides. Then I'll multiply both sides by 5 to do the opposite of the division, and I get x equals 70. Because 5 times 4 is 20, 5 times 10 is 50, 50 and 20 make 70. Okay, for this one, the 5's farther away, so we'll subtract 5 from both sides. I get 2x over 5 equals 2. And you can do this next part in one step or two. So for some of you, it might be more straightforward for us to just say, well, we'll get rid of the 5 next because it's farther away from the x than the 2 is, because it's on the bottom while the 2 is with it on the top. So let's do that way. Multiply both sides by 5. So we get 2x equals 10. Then last thing to get rid of is the 2, so we divide by 2 and get x equals 5. But I want to show you that you can do it in a little quicker way if we do this. So 2x over 5 equals 2. So I already did the minus 5 step. I'm starting where we were here. If you want, you can actually get rid of this entire fraction, the 2 and the 5, by multiplying by the reciprocal. Sorry about that, guys. Multiply by the reciprocal of 2/5, which is 5/2. So you see the 5's cancel, the 2's cancel, leaving just x. The 2's cancel, so we just have 5 over 1, which is 5. But both methods work perfectly fine, so you pick whichever one you like better. Number 7. 17 is 13 subtracted from 6 times the number. So remember, subtracted from is that time that makes it backwards. So 17 is, we do 17 equals, but we don't write, 13 next, because the subtracted from means we do it backwards. So we write 6 times the number minus 13. So we've written this sentence as an equation. The is equals. Subtracted from, meaning we put this first and this second. And they say, what is the number? So we have a two-step equation here. We need to add both sides, add 13 to both sides. It gives us 30 equals 6n. Then we divide both sides by 6 and get 5 equals n. Okay, 8 and 9 are a little trickier, so I'm going to do my best to explain it. It says find 3 consecutive integers with a sum of negative 36. Consecutive means in a row. So these are not the numbers we need, but 2, 3, 4 is an example. Those are 3 consecutive integers. Or 7, 8, 9. Those are 3 consecutive integers. So first of all, we see the word sum, so we know we're going to be adding them. So 3 consecutive integers. We have no idea what these are, but we know they're consecutive. So here's what you need to think about. If we start with the smallest number, in this case it'd be 2, in this case it'd be 7. But we don't know what the smallest number is. So we'll just say it's x. So that's the first number. And we need to add to that the second number. So I want you to look right here. Again, we don't know what our number is. It's probably not 2 or 7. But when we see consecutive integers, how far is it to get from the first one to the second one? The second integer is exactly 1 bigger than the first integer. 3 is 1 more than 2. 8 is 1 more than 7. And if this is our first integer, the next one is going to be 1 bigger than that. Now, you don't have to draw these parentheses. I'm just doing it to help us think like, okay, this is the smallest number. This is the second number, the one in the middle. And then if you look from the smallest to the biggest number, they're 2 apart because it's gone up 2. So to add our third number, we'll do x plus 2. And we know the sum of those 3 numbers, if we add all these 3 together, the answer will be negative 36. Okay, we see x plus x plus x, so that's 3 x's. 1 plus 2, that's 3. We know that's all equal to negative 36. So I'll subtract 3 from both sides. I get 3x equals negative 39. Divide both sides by 3. We get x equals negative 13. So that means, actually that's not a final answer because it says find 3 consecutive integers. So that's the smallest one. So we need to add 1 to that, negative 12. Add a more to that, negative 11. Those are our 3 consecutive integers. If you add those 3 together, you do get negative 36. Okay, 9 is very similar, but this says find 3 consecutive odd integers. So they're still in a row like the others, but they're odd. So that could be like 1, 3, 5, or 15, 17, 19. Those are both examples of 3 consecutive odd integers. So we're going to use a very similar pattern to what we did last time. We're going to start with the smallest number. We don't know what it is. We'll just call it x. But this time, because we're only using odd numbers, to get to the one that's bigger, the next one in the line, we have to add 2. 1 plus 2 is 3. 15 plus 2 is 17. So we have to add 2 to get our second number. So again, this represents our smallest number. This represents our middle number. It's going to be exactly 2 bigger than the one we started with. Now for our biggest number, our third number, if you look from 1 to 5, we have to add 4 because we have to add 2 twice, plus 2 plus 2. To get from 15 to 19, we have to add 2 twice, plus 2 plus 2, so it's a total of plus 4. And they told us it has a sum of 75. So we'll add the x's together, you get 3x. 2 plus 4 is 6. We subtract 6 from both sides. We get 3x equals 69. Divide both sides by 3. We get, we get x equals 23. So remember to stop there. They didn't just ask for the smallest number. They wanted all 3 consecutive odd integers that add up to 75. So 23 is the first one. The next one would be 25. The third one would be 27. So those would be the 3 consecutive odd integers that add up to 75.